So hello, good afternoon, everybody. Hope you all can hear me. Or good evening, good morning, good afternoon, wherever you are based on where you're dialing in from. My name is Curtis Evans, and just wanted to welcome you all to a session today here with the Beam Path. I'm certainly super excited to have you guys join me. I'm broadcasting from rainy Atlanta, Georgia today. But more than happy to spend my Saturday with you guys to talk to you a little bit about cloud computing. I basically titled this session, The Cloud, Foundations and Concepts. I do have some slides here that I'm going to provide as, I guess, just consider them basic talking points about what we want to discuss today. But I always find it best to engage with attendees and audiences so that I'm making sure that I can provide what it is exactly that you guys want. So you use the deck as a guide, but certainly feel free to pop in any questions, and I would certainly love to be able to answer them for you. Real quick, just a little bit about me. So again, broadcasting from Atlanta, but I'm a native of Columbia, South Carolina. I'm a graduate of Clark Atlanta University and Georgia Tech, where I was part of the dual degree engineering program. So as you can see, I have degrees both in physics and in electrical engineering. I have over 20 years of industry experience here. It's actually probably closer to 25 now. Time flies when you're having fun, as they say. But I've been in technology for years now. I've had roles as a systems administrator. I've been a developer / programmer. I spent a few years working as an independent consultant where I was helping companies build, manage, and operate data centers for their large organizations. And then I've been with Amazon Web Services for the past 6 years. Really been focused on cloud for these past 6 years, almost exclusively. And then just to give you an idea of the type of work that I've done within this cloud space, I've been responsible for either designing or deploying solutions to cloud, whether it be for mobile restaurant ordering. Think about those services that allow you to connect with DoorDash or Uber Eats, or even with the restaurant directly to place your order, use your credit card to pay for it. And basically you just drop by and pick it up if it's not, or otherwise, if it's not being brought directly to you. I've also worked with some of the biggest names in the entertainment, sports, and news industry as far as being able to bring some of their streaming apps to life. So the next time you sit down and you go to watch your favorite, binge watch your favorite TV show or watch a movie on one of the popular streaming apps, just know that a lot of that actually runs on cloud services as well. And then I've also worked with digital print and media organizations, as well as some of the cruise lines. Believe it or not, when cruise ships go out to sea, they do have compute technology that are on the ships, but oftentimes when they bring those things back to shore and they look to switch over to get the whole new line of passengers out to sea, a lot of what they do, along with just bringing more food and other resources on the ships, is that they offload data as well too. So a lot of people don't realize how much technology is used within that space, but it definitely is. So I left this screen here blank. We're going to just kind of level set first in terms of just, I think all of us on the call here understand what it means to, or what traditional computing means today. The world as we know is just dominated by computers. They're everywhere. For those of us that are technologists or budding technologists, whether we are going to be developers, system administrators, network engineers, what have you, it's our responsibility to kind of move ourselves or be those, I should say, that are responsible for doing the development of applications, of solutions that bring those technology capabilities to customers, to users, to basically provide a better experience. Just to help put some of that into perspective, if you think about the entire technology industry as a whole, when you look at the amount of spend that's put into this industry globally, whether it's buying hardware and software or providing services or running applications, globally, it's a $5.2 trillion industry. And that's huge. what I'll talk about mostly in the context of traditional computing and how it relates to cloud. We won't be able to get into it all, but I'll use like just website hosting as an example. We all have touched and used websites in our lives. Hopefully a lot of you guys out there are learning to become better web developers, programmers, administrators as well. But we'll just use websites just to kind of help guide us along today. Now, as successful as traditional computing has been up to this point, there is some of the problems that went with it that cloud computing is certainly trying to solve. The first is what I have here is just the means of buying a server. And just for clarity, when I say server, I'm talking about a server as just a large computer. If you think about the desktop PC that you have at home or a laptop, a server is just a bigger, faster, more robust, and sometimes more expensive version of that. And those things are designed to support more than just one user. So anytime you go to a big popular retail site, if you go to one of the streaming web services I just talked about, think about you connecting to a server to kind of help you get your experience going. So hopefully that helps there. But yeah, one of the problems with hosting websites using traditional computing resources is that you've got to spend time buying servers. You got to start worrying about, well, how much traffic am I going to have? And am I going to build systems big enough that are going to be able to support it? Another thing you actually have to think about when you basically run your own operation using traditional computing is that you're going to have to be responsible for all of the monitoring and maintenance that goes along with that as well. Just to kind of further accentuate that, again, some of the additional pain points that you're going to incur is that you're going to have to spend money up front, not only for the hardware itself, but maybe even buying support contracts and things like that to help get yourself going. The organization is also going to be responsible for the troubleshooting as well. Troubleshooting, as I've known throughout the entirety of my career, is that it can be very hard to do sometimes. It can be very tedious. And the thing I hate most about it is that you're so focused on what's wrong with the systems that you start to lose sight of what are the things that you're actually trying to do for the business and the customer. So that's never a fun thing as well, too. And oftentimes that can just end up in just kind of this myriad of inefficient use of the hardware and resources that you have, even during the stages of development and setup. And especially when your traffic starts to vary and in the worst case, start to increase. I don't know how many times organizations or businesses have had success where they've successfully built a website, they've got it up and going, but the one most important thing that they haven't focused on is how are they going to be able to handle things when the traffic starts to scale? It's one thing to be able to support 10 or 100 or 1,000 users, but when you start getting into 10,000, 100,000s of users, you got to be able to have the resources and the capacity to be able to support that as well. So that's going to kind of lead us into where cloud computing comes into kind of save the day, if you will. The first thing I want to do is just to kind of help set some context is let's define what cloud computing is first. At AWS, we like to establish a kind of a formal structured definition of what cloud computing is. And I'll read this here for you, and then we'll break it down a little more in detail here. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. That means instead of having to go and buy and own and maintain physical machines or even within inside of a data center, the servers and stuff that I was talking to you about a second ago, with cloud computing, you can actually access all of these services along with just not only just compute, but there's storage, there's databases, there's all other types of services that are available to you as well. And then you can do it on an as needed basis from a cloud provider. Just want to analyze or maybe go a little deeper into some of what we're talking about here. Here you can see I've got bold and highlighted on-demand delivery. On-demand delivery means you get to it whenever you need it. Go back to the example that I just said ago about the successful website that's good for 100 users, but may not be good for 10,000 users. With cloud services, you can go and build that site that you need just to support 100 users in the beginning. And then as you start to grow, linearly or exponentially, depending upon the rate, you then can go and start adding on more services to accommodate those additional users. Cloud provides a great model in that respect because you don't actually have to run out to the store, buy more hardware, and then go back through that whole rigorous process of setting it up, worrying about the maintenance, et cetera, et cetera. I also emphasize over the internet. With traditional computing, you literally have to be inside the room with the resources to be able to build them. With cloud, that's not the case. If we get an opportunity to do so a little later here, I'm actually going to show you by way of some services and tools that I have that I can actually go out and access a computer in Tokyo, Japan, just as easily as I can right here in the on the East Coast of the United States. Just to go through this definition a little more, I emphasize at the bottom on an as needed basis. Again, it's when you need it. And one of the things I wanted you guys to think about in terms of just some of the other business or industry examples I was talking about, think about how that helps a retail business or a streaming media service. On an as needed basis means if I'm a retailer, I need more resources during peak shopping season than I do, during off-peak season. Think about Black Friday, after Christmas shopping, other big holidays and sale seasons around the year. I have the ability with cloud resources to go and get those services when I need them, use them to improve my customer experience, increase my sales, and then be able to get rid of them without having to pay for them when I don't need them anymore. Same thing can be said about streaming media services. I'll use the name Netflix. We're all familiar with Netflix. Netflix probably has more people watching shows and movies on a Friday night than they do on a Tuesday evening. That means Netflix has the ability as a streaming media service to be able to meet their demand by being able to procure or at least provision and make available more services on a Thursday or Friday night than they do on a Tuesday evening. And it's not so much just a day or time of day driven thing. Even when unexpected demand comes up, they too can do the same to make sure that they've got enough resources to be able to provide for their end users. So again, we're talking about cloud computing here in general. We talk about using cloud resources to store data and applications on remote servers somewhere. Everything is accessed, whether it be data or some portion of the application, over the internet. We all use our phones to connect to services and things that we need to do, or our computers at home. Again, that always used to be just an end user thing. Even people like myself who are solutions architects or programmers or developers, we access the services to build them the same way customers and end users access them to leverage them. That's kind of the different thing that cloud now does for us today. And we're also able to process data on remote servers. And when I talk about data, I'm talking petabytes and terabytes and zettabytes of data. I would encourage you guys to go look up what some of those terms means as far as just the order of magnitude of how many bits and bytes that are being processed, not only every day, but annually as a result of cloud technologies and just technology overall in general. If we start to look at this from more of a layered approach, what I'm showing here is these are basically all the components that are involved with a traditional compute infrastructure. Again, you've got to have some space that's available to you. You've got to be able to provide your own power. You've got to be able to cable these things up so that they can connect and communicate with each other. You've got to provide the networking components. You've got to store them in racks, on and on and on. This is all going to say that there's a lot of work that has to be done. And depending on what it is that you're trying to accomplish, it could actually take weeks for you to get it done. What makes things different about cloud, and specifically about a service like AWS, is that oftentimes you need very little to get started. No money, in fact, and that's just that's factual, because quite frankly, before you actually go and start using those services, you do have the ability to go and set up your environment. In some cases, be able to use some free services to try to check things out and make sure that those are going to be the kind of resources that you need in order to get things done. With physical servers or with traditional computing and who you acquire those services from, oftentimes you have to deal with things like contracts. That's not so much the case in cloud. It's more of a pay-as-you-go model. And then whereas it takes maybe weeks to do things in the traditional computing world, you can actually get them done in a few minutes with cloud. So hopefully that just provides a little bit of groundwork into what we're going to talk about here a little more. Three things I want you to start thinking about as we talk a little more are things that we refer to as agility, innovation, and scale. Agility in the sense that with all of these cloud resources available, with all these different service options that you have, you can move a lot more faster with a lot more things available to you to be able to meet the needs exactly when you need them. The innovation portion is that it gives you new and interesting ways to think about the things that you want to do. And I already talked a little bit about scale in terms of being able to grow and grow fast. What I'm showing here is basically a layout of the AWS global network. Here, what I'm illustrating is that by being such a large cloud provider, we have locations, facilities, resources all over the globe. If you kind of look to the left of your screen there, starting as far left as the West Coast in the United States and working our way all the way over to the right, as far right as places like Sydney, Australia. Those blue lines representing the connectivity between the green and blue dots basically represent the network connections or the network pipes that allow all those services and resources to connect to each other. These are the types of connections that allow people in places like Europe and Japan and Africa to be able to access services like Netflix that originate out of the United States as well. Conversely, think about, I'm a big race fan. I love Formula One racing. And if I want to be able to watch a Formula One race that's running out of Dubai or Monaco, somewhere outside of this country, and I stream it over the internet, this is just an understanding of how some of those broadcasts are being brought to me across a large global network. And again, this is just Amazon Web Services representation of their network. There are many other companies and services like an AT&T or Microsoft or whoever that's able to provide this same type of network connectivity across the globe. I want to talk a little bit about just cloud models in general, and I'll define some of these a little more for you here in just a second. When you think about cloud computing, you'll often hear jargon and terminology broken down in terms of the various types of service models and deployment models. Just to start over to the right here, when you talk about deployment models, a lot of what I've been talking about is public cloud, meaning that we are talking about a service like AWS or a service like Google Compute Cloud, where we in the public can go and procure and access services from them. Hybrid clouds are a little different in that they consist of both a little bit of public cloud and a little bit of private cloud that companies themselves can own. They often take advantage of being able to leverage the two so that they have a little more control and flexibility over some of the things that they want to maintain and manage in their own facilities versus anything that they want to put out in the public cloud space. And then there's private cloud altogether, where everything is done and managed in a private space. I put the asterisk up there by cloud models just to kind of indicate that while these are kind of general concepts, not everybody subscribes to them. I know we at AWS tend to just refer to ourselves as an enterprise IT company. So we regard ourselves as just kind of a little different in that respect. But the definitions certainly still do apply here. If you think about the first service model there, that IaaS stands for infrastructure as a service. And this is the type of service that will give you access to those fundamental resources that I was talking about, like computers, like storage, like databases, et cetera. Again, these are all set up in a facility somewhere, powered up, secured, just ready to go for when you need them. You just basically have to have the means through an account and access over the internet to go out and get them. And then again, you're going to find that available with most of your cloud providers. A platform as a service, it's a little more than just the infrastructure as a service. With infrastructure as a service, you're more or less going to build everything you need. Whereas a platform as a service is already going to give you some of those things ready to go. So with platforms, you have less control over some of the operating systems that you may want to access or choose. Same thing can be said with the storage and the servers. Now, sometimes that doesn't work for some organizations based on what they want to build. Other times it works great because those organizations want to focus more on their business and don't want to have to worry about those things that we're talking about right there. A quick example is there's a service called Amazon Elastic Beanstalk. And basically what Beanstalk will do is it gives you an easy way to stand up a website. You just tell the service that, look, here's all of my application code. Here's my static HTML. Here's everything I want for my website to be up and functional. You go handle everything else. And if you see those little towers there to the right, what those are trying to show is that in the infrastructure as services tower, you're mostly responsible, again, for the operating systems, the databases, the applications, data, et cetera. With the platform, you're responsible for less of that, typically just the data and the application. And then lastly, I won't elaborate on this more, too much, but the service model is probably the simplest of the cloud computing models here. It's basically everything ready-made for you. All you have to do is supply your data. You connect to the service, you set up a few accounts, you throw your data over the proverbial wall, and then you're ready to go. Perhaps maybe some of these names that I use as examples might be familiar to you. Salesforce, which is a large customer resource management company, allows businesses to be able to manage their sales and management and contact pipelines with an entire suite of services. All they've got to do is bring their data and the things that they need. Dropbox is kind of similar to that. If you've ever shared files with somebody before over a Dropbox link, that's all you have to do. You upload the file, your recipient accesses the file, nothing else needs to be done. Office 365 is another example where me having been in industry for so long, I've worked with email systems for years, and I remember what it used to be like to actually have to go in and manage an email server. It was never a fun task, quite frankly. Office 365 puts all of that in the cloud, makes it a whole lot easier. So, and again, as you can see, it's mostly just a data component there. So again, quick reminder, while I talked about the infrastructure as a service, the platform as a service, and the software as a service, again, here at AWS, we're more of an enterprise IT company. We like to enable business and developers to use web services, what we refer to as the cloud, in any way that they want to build the services that they want to use. With that understanding, if we want to try to go back up through those stacks, if you think about certain database types or certain storage components. In the traditional IT world, you'll use things like storage area networks, you'll use things like network attached storage, and then you'll use databases that use languages like SQL to be able to build and manage everything. Over there to the right are just some of the AWS readily available services that can provide similar capabilities and access for you. The same thing here with compute. You've got just a bunch of different compute options that are available to you in the AWS world, whereas in the traditional compute space, you've got mostly servers available to you. Same thing can be applied to networking equipment, as well as other security services like firewalls and access control lists and administrators. One thing I want to do real quickly here is I'm showing you a lot of this kind of by way of illustration. What I want to show here now is, if everyone can see this, I'm actually inside of my Amazon Web Services account right now. So as I talk about all these different services and everything, and as I've talked about being able to go over and access all of these things over the internet, here you can see that over the internet, I now have access to my Amazon Web Services environment. And let me just bump it up a little bit here, so hopefully everybody can have a better look at it here. As you can see, I'm connected to resources in my Northern Virginia Amazon Web Services environment. If I take you back quickly to the networking graphic I showed a second ago, I talked here about the AWS Global Network. Because cloud computing is a service that allows me to access things over the internet, then I should be able to access things in Northern Virginia just as easily as I can somewhere over in Tokyo or in some foreign land. So why don't we run through and see if that's the case? Here I am in Northern Virginia. Here I am showing you where I have some computer resources that are available in Northern Virginia. These are just a bunch of virtual servers or computers that I've stood up and that are running and available to me to build applications over in Northern Virginia. Could I do the same in Tokyo? Absolutely. So just by way of a simple web call or an API, as we refer to them, I now switched over to my Tokyo environment. And here you see, I actually created this little machine last night. It's up and running. I called it Beanpath because, you know, we're now operating in the Tokyo region. And here I have an actual server allocated and made available to me that I can run here from my house in Atlanta, or access from my house in Atlanta over to Tokyo. Again, the same thing with what I have here in Northern Virginia. And what I'm showing here to the right is basically this is just a terminal session that I have on my computer here at home. What I also wanted to demonstrate to you is just to understand the kind of scale I talk about when you're talking about accessing services or resources that are closer to me in Northern Virginia versus something that is way out here in Tokyo. What I want to do real quick is do just a simple operation, which is called a computer ping. And for those of you that may not be aware, when I go out and ping a resource, it's just a way to go out and say, hey, are you actually available or are you not? When I run this ping command against this IP address or a number that's going to identify one of these servers in Virginia over the internet, if I go and ping it, if you notice, I'm getting basically a positive response. And what that ping does is it basically sends a packet or two of data to the server acknowledges it, and then I get that acknowledgement back to me. And this is basically measuring the response time or the round trip time in which it takes to get to and from. Here you can see that basically all of those connections, those requests and acknowledgements basically averaged around 32 milliseconds. Going over to Northern Virginia. When you talk about high-speed networks, when you talk about data packets moving over the internet and using, you know, kind of the concepts of the speed of light, that's pretty fast. Distance alone should tell me that while Tokyo should be pretty fast as well too, it probably won't be as fast as Northern Virginia. So let's go and kind of put that to theory. Okay, here are my tests over to Tokyo. Again, 32 milliseconds to reach the computer in Northern Virginia, 179 milliseconds to reach a server over in Tokyo. So hopefully that makes sense. And it also resonates when you're talking about where you want to build your services for your customers. So just something to think about there. I wanted to provide that. It's just kind of a really simple illustration in terms of, not only me having the ability to go and access cloud resources wherever I am, but just giving some context in terms of what it means to be able to go out and touch and reach servers across the network. If I'm a company or if I'm a business looking to build applications where most of my customers are in the United States, then it probably wouldn't make a whole lot of sense for me to be able to go and start building resources in Tokyo. I want to build most of those services here in the US where it's going to be closer to my customers. Now, that said, if I'm a global company, think of a large retail company that wants to sell merchandise all over the country, all over the globe, then they probably want to be able to put resources and access to their shopping experience in the United States, in Tokyo, in Africa, everywhere. So that based on wherever a user is, then they can connect to and have access to those resources in that location. Just want to pause real quick to see if there's any questions from anyone. And again, I hope this is helping you guys get some sort of a foundation of how the differences of traditional computing versus cloud computing has been gone or been evolving over the years. And again, I certainly want you guys to take an opportunity to kind of engage with me as much as you can. So I would love to see if there's anyone out there that's got any questions that I would be able to answer for you. Okay, if not, I'll go ahead and move along. If you think about the scale I talked about earlier as well too, and the innovation that cloud computing and cloud services can provide for you, all I'm representing here is just kind of the foundational components of what what cloud services can provide as an organization. We're talking just storage and databases here. We're talking just compute. We're talking just networking services. We're talking about security. That's really just the tip of the iceberg. If I really wanted to start expanding and showing you an understanding of what the global product landscape is for a cloud service like Amazon Web Services, there's just a ton of services offered. This big number I have here in the middle, I don't want you to confuse that as me saying that we've got over 3,084 services. What we've done is just since 2021 alone, in the year 2021, we actually included an additional 3,084 improvements, enhancements, and updates across all of these services that I'm illustrating here, kind of on the edges here. A lot of these things fall into categories that you all as learners and up and coming builders might be able to associate with, whether or not you're involved with things like artificial intelligence and machine learning, or Internet of Things devices, or just basic programming. If you're a budding security specialist, a lot of these services are going to be available to you as well. If I take you back over here to the AWS console view, we have been talking mostly about just some of our compute services. Again, if I take you back to the main dashboard, here is where some of those other services can be accessed. I'm actually not even providing a full view here right now. But again, if those of you are familiar with the concept of containers, here's a link that I can take you to some of our container services that we have here. I talked a second ago about security. We have a service, it's called Identity Access and Management. And basically it provides the building blocks for how you use cloud resources to go and provide improved security. A quick example I can probably provide that helps you understand the different layers of security. If we're talking about providing or building a website that's accessible over cloud, the level of access you want to be able to give end users to the website is going to be very different than the access that you're going to be able to give to the administrators who are responsible for managing the website. The administrators are going to be more responsible for the entirety of the site. So they're going to have access to a lot of places, whereas end users have very limited access just to be able to make requests for services, whether it be ordering products, accessing their banking information, etc. One of the things that the industry has had to struggle with for a while is that oftentimes when organizations don't do the right thing from a security perspective, that's when you start hearing stories about, hacks or people getting access to sensitive data that they never should have gotten access to in the first place. So again, going back to us as being the technologists or the keepers of the gate, we always have to make sure that we're doing the right thing from a security perspective, so that not only in the code that we develop or the services that we provision and configure, but we have to be able to talk to the business organizations as well to make sure that everything's being done properly from a large scale security perspective. And again, just to kind of summarize here, more broadly speaking here, when you talk about some of the advantages that are made available to you from a cloud computing perspective versus what you've done in the traditional space, with cloud computing, you don't have to so much guess as to what services that I'm going to need. Think about what your business needs first, and then you can land on the service that you need. I go back to the screen a second ago. With the cloud environment, all of these services are going to be available for you at some point. They're already up and waiting for you to use in your accounts You don't actually pay for them until you need them. So that's very different from a traditional computing organization where, say they decide one day, oh, you know what, we're going to need some artificial intelligence capabilities to be able to build a better customer experience. If they don't already have some of those things on site or within their facility, they've got to start from the very beginning to go out and access those things that they need. Whereas with cloud, it's just a matter of going out here and saying, I need some machine learning tooling. What's available to me? Here, we start to see some of the different services that are going to be available to us. We click them, and then almost instantaneously, we're able to go out there and grab those resources we need. Same thing can be done for various storage services. If you look at it from a compute perspective, there's basically 500 different compute instance types that you can have within a service like Amazon Web Services. If I go out here and if I were to walk through what it means to go out and actually start a new server, I could go out here and just in a matter of minutes, I could say, okay, I want to create a test server. I've got my choice of operating systems that I want to use, whether it's a Mac OS machine, whether it's a Windows machine, or whether it's different variants of Linux machines. Not only do I get to choose the machine type, I can select the different architecture. I can even go in and start specifying how big the machine needs to be. So again, this kind of speaks to all those different sizes and shapes and types of compute infrastructure that I need to do my services here. And then that all leads to the ability to go to market relatively fast. We've already talked a little bit about some of the agility and the scale. Again, they're there if I need them. And if I don't need them, I don't pay for them. Goes back to the example of what I was talking about being able to scale up for seasonal sales, or if I'm wanting to do things on a Tuesday or a Friday night. I'll pause here. It looks like I have a question available to me. What are some resources to learn more about cloud computing? Oh, great question. Yeah, so within the AWS environment itself, there's lots of learning and computing options. I'll even pop up here to just, if you go to aws.amazon.com, not only does it have resources that you can go out to look at and start looking to leverage services, you can come out here and go to this learning link. And over here in the training and certification location, you can start looking into some of the different training and certification options we have. And again, that's just for Amazon Web Services. Also, you leverage Google searches for just going out and finding a plethora of other resources that are out there. There are lots of third-party entities that work with us to provide training and certification options as well too. Names like A Cloud Guru, I'll bring up here, is also a good potential option for you. I think they may have actually been acquired by a different company now. Pluralsight, yeah. If you go look up Pluralsight or even A Cloud Guru, in fact, I think they just made available an option where you can actually go out and get several free classes or several free modules for training that are going to be free until the end of the year. So definitely go out there, look for this opportunity, and take advantage of some of those options. So again, acloudguru.com, or you can even look up Pluralsight, and then just look to land on this page, maybe sign yourself up for an account and start learning. So here's two good ones right here: AWS training and certification, and the A Cloud Guru site there. Okay, what I also wanted to show real quick, and this is a great segue into the question that was just answered a second ago about how you go about and get AWS certified. What I'm showing here now is just a sample diagram of what it looks like to actually build an application within the Amazon cloud. What I'm showing here is, imagine if I went through my account. I'll go back to the AWS account here. If I went into my account and I started provisioning a lot of these services, compute, networking with my virtual private cloud capabilities, being able to start building security and the things that you're going to need to ultimately arrive at some sort of a workload or solution that your customers can use, this is what that's going to look like. I'll just kind of briefly walk us through this. What I'm showing here up top, the little cloud at the top, is basically representing everything that's out in the internet. Again, we talked about the same way I will be able to go over to internet to build these applications. End users are going to come in and be able to access them to use them for some sort of a customer application or some other experience. Again, it's all about the different security rules that decides, am I coming in as an administrator or am I coming in as a customer? That ultimately determines what sort of access I get. But anyway, what this thing is showing here is that once, and I'll talk about it from an end user's perspective. Once an end user goes out to a website URL, Amazon.com, CNN.com, Netflix.com, whatever, they're going to hit a web server that's going to provide them with some sort of a UI or user interface to allow them to take the next step into what it is that you're doing. You know, in the case of a Netflix application, you're going to be there to log into your account, authenticate yourself as a user, and then be able to go and either watch the next episode of a TV show that you're watching, or go browse through some other options available for you to watch. By contrast, if it's a banking application, again, you're going to log in and authenticate, verify that it's you, and then you're going to start having access to your banking information. What's my current account balance? You know, am I able to go in there and transfer some money or you know, pay a bill or something like that? And understand too that this cloud representation at the top, it could be done from a browser, it could be done from a mobile phone, it could be done from an iPad, basically any tool that's going to allow you, as we all do every day, to go in and access everything. At the bottom here is what I'm showing is some database services that we have, where in addition to being able to go out there and access that user interface and be able to make requests and ask questions and input information, a lot of that information has to be stored somewhere, or what we refer to as persist. It's going to be stored in a database somewhere. It's going to be stored somewhere in some sort of storage facility. You've also got all the different images and pages and streaming movies that you're going to eventually access. That's going to be stored on storage as well. Some of you may be asking, well, why am I seeing two of these? The reason why is because if we go back to talking about the reason we build these applications and resources in the first place is that we want to make sure that our customers can have a really good experience and they can access these practically anytime they want. Resources in the cloud, as they do with traditional computing, can fail at times. The beauty in cloud is that if you're working on a server in the cloud somewhere and it's reached its end of life and it fails, the beauty is that you can switch over to new resources almost instantaneously. That's not always the case in a traditional computing environment. I'll go back to one of those graphics I showed at the very beginning here momentarily. If I'm buying a server, as I talked about earlier, and I'm responsible for the monitoring and the maintenance, if I buy only one machine, then once that machine goes bad, I've got to repeat this process over and over again. Am I in a position to be able to go out and buy 2, 3, 5, maybe 10 servers at one time? That can get very expensive. And even if I do, I've got to still spend the time to go out and replace the broken machine with those new machines in the event that it happens. Very different in the cloud space. I can build or deploy 2 smaller services and basically balance my traffic across the 2. So that if this computer goes bad, then I can send all of my traffic to this computer while I'm replacing this one. I mean, that's golden in terms of the way businesses are now able to build more what we refer to as reliable websites. Again, having been around in this industry for a while, I can remember not only before cloud computing, but before companies got better at building scale in their applications. There would be days where a website that I like to go out and visit would be down for hours, if not days at a time. And the reason why that outage was out for so long was because they took time to have to go out and replace some of the equipment in the background. That kind of thing was understood then. Cloud has changed that completely. With cloud today, everybody, and I'm sure we've all been guilty of this. How many of us get really frustrated when we try to go to one of our sites that we know and love, and you can't access it for a couple of seconds, if not a few minutes? That feels like an eternity. Because I think we as end users have gotten so used to the fact that these sites are always up that we never expect them to go down. The reason why is because the design and the deployment are being created now so that those things never can go down. So think about this as kind of the minimal requirements when you want to be able to leverage cloud technologies to be able to go out and build anything. So again, as far as slides are concerned, that's really all I had. I am very much hoping that the crowd would be a little more engaged and would ask some questions. So again, I'm going to give everybody an opportunity just to ask a question or two. I do have my information up here as far as where you guys can reach me out on Twitter or LinkedIn, just to get an idea of what I'm doing in this space. On Twitter, I'll occasionally just kind of engage with some of the other people that are actually learning more about IT and trying to build their careers. Occasionally, I will provide some instructions or some details about how a service is being used or how an application can be developed. I'm starting to build up a little more content around, some of the programming aspects of what it is that I do. And it's not just me. Take advantage of resources like Twitter and LinkedIn to be able to go out and find out other things, not only about AWS, but cloud services in general. Find other good followers out there that talk about how to build IT careers, that provide resources or links to resources to other free services, because again, there's just so much out there. One other quick shameless plug I'll make is that we at AWS also have a YouTube channel. If you just go out to YouTube and do a search on Amazon Web Services, you should be able to come up with an AWS-based channel where there's just going to be a large volume of presentations and sessions and tutorials and how-tos that you can go out and access as well. And a lot of what you'll see is that when they talk about some of the things within those sessions, they're going to be accessing the AWS account the same way that I'm doing. They're also going to be using their command line directly on their machines to be able to go out and connect to some of the services as well. One of the things I did earlier, all I did was an actual, just a ping check, as I referred to them when I was going out there and accessing those machines. I'm going to go out here and show you what it would be like if I were just to go out and actually connect to one of those, that Tokyo server. Let me see if I can't do that real quick here. And while I'm doing this, I will just kind of pause and give you guys an opportunity to ask a question or two if you have them. Let me see if I can connect to Tokyo here in real time. Let's see if this will work. Yep. See, and again, this is a very simple command that I've just run here, but I'm now actually connected to the computer all the way over there in Tokyo. So now, just as if I was sitting in the room with the computer, I now have the ability to go out here and, check the software, go out and perform. Here, I'm just accessing the server and I'm going to do some software updates. Again, imagine the ability and the power to be able to sit from the comfort of my home here in Atlanta and be able to go out there and start doing things to a computer all the way over in Tokyo. Businesses do this all the time. Looks like we did have a couple of questions come in here, or at least one. Along with SQL, are there other programming languages that Amazon engineers use? Absolutely. Pretty much all of the popular programming languages of today, Go, .NET, C++, Java, JavaScript, Python. A lot of Amazon services, or excuse me, a lot of Amazon engineers use. A lot of the, in fact, this machine that I'm on here, because it's just a server, because it runs an operating system like Linux that has the ability to go and run practically any language that I want. I don't think Python's installed on this right now. I will check real quick. Actually, it is. I have a version of Python that's already installed on this machine here. So if I'm a Python programmer, I probably wouldn't use, and I'm having to navigate around my smaller screen here, excuse me. Yeah, I've got a version of Python 2.718 on this machine here. If I wanted to go out there and upgrade that to Python 3 to use the latest version of Python, I most certainly could. Let me see if it's got Node Package Manager or some of the other Node components on there. Okay, doesn't have anything related to that on there. But yeah, but just to answer the general question, we as a enterprise services provider, we don't pigeonhole our end users into choosing the things that we want them to use. We give them the opportunity, or give you the opportunity for that matter, to bring the tools and resources that you've been using forever to the platform. So when we go and build an SDK or a software development kit that allows you to be able to programmatically go out here and access these services, we will provide multiple languages that support them. One of the things I showed earlier when we were in that compute realm, you guys may not have heard of a service called Lambda. Lambda is basically what we call a serverless compute service, meaning you don't necessarily have to run code using servers. We provide the infrastructure for you, and you can go out here and basically just upload your code to a Lambda function, and you can go out here and build whatever it is you want. And where I am here in the console now is, say I wanted to go out and use Lambda for a function. And just to give a little better context, an example use case of how Lambda could be helpful is, think about if you built an application that's going to allow customers to upload and manage photos and videos. Photos and videos these days come in very high resolution. Once an end user were to upload that image to your cloud application, that could be a signal to trigger a service like Lambda to say, okay, I don't want you to store this in this big high resolution format. Go and run a transcoding job that's going to reduce the image resolution or quality of that photo, so we can store it a little smaller. We'll re-encode or re-enlarge it again when we want to view it again. But Lambda is a great service that can be used for things like that. It's also a way to just, again, I go back to that kind of pay for what you use concept there, is instead of having to go out and provision a large computer or many computers to go and do some of your work, you can do it with a Lambda function. But anyway, Lambda will actually give you the ability to choose the programming language you want to go and build your Lambda functions. So in the same vein about asking the question of what other programming languages that are used, again, .NET, .NET Core, there's Go, Node.js, Python, so on and so forth. So yeah, if you're learning a particular programming language today, I would almost expect that any cloud environment that you use should be able to support that language. At a minimum, the virtual server that you can go and use to be able to start learning more should be able to support that that language you want to install, load, and work with as well. So hopefully that answered your question there. Any additional questions from anyone? I know we're going to be coming up on time here real quick, and Ada, you guys keep me honest on where we are with time. I want to make sure I'm spending enough time with the participants as needed. I'm happy to stick around and answer any questions if there are any more. Okay, if there aren't any more questions, again, I want to thank you guys for joining me today. I hope you found this information useful. This is just the tip of the iceberg, as I mentioned in that one graphic. This wasn't necessarily talking about just AWS services. Think of this too as just where you guys can take your career. Learning is just the first step in the journey, if you will. Don't think you're going to be able to learn it all overnight. Just identify those things that you're passionate about, because I think once you identify the things that you're passionate about, it makes it easier to learn. It becomes less of a job or a task and more of more fun. So think of the tip of the iceberg as just those things and activities and opportunities that you'll have if you start to just consume a little bit of technology and learning every day. Start with lab 1 and then just work yourself through an entire module, whether it's something that you discover on the A Cloud Guru site that we talked about earlier, or if it's something that is recommended in the AWS training and certification that's available. Make it a journey and enjoy it every day. And then I would certainly love to see our paths cross at some point. Again, if you want to just connect with me on any of these resources, remind me that you were in attendance on the session we had through BeamPath today. I'm sure Dr. Cephas would want to hear about how some of the attendees are doing as well too. I see Dr. Nashley over at our offices pretty regularly, so I would love to be able to report back to her that we had a good session today. The crowd was really thrilled about what we shared, and then they're making strides to just get a little better every day. So again, want to thank you